Hi everyone, how is everyone doing? Good? Yeah. Okay, so today's topic is kind of personal, and I think everyone in the industry face this issue. So how many times have you worked on a production incident on weekends? Yeah, everyone, I think. Yeah, and even if it was a successful deployment, you have worked on that, and you are thinking like, yesterday I deployed it, it was green, and my test case were passing, and still we got the incident. That's pretty strange, right? And it adds up a lot of work to SREs and developers and working over the weekends. So we usually hear this term like, don't deploy this on Friday, please, because it will spoil our weekends, right? We have all the plans ready. So we don't do that, but what is happening is all our test cases were green in lower environments, in staging, in development. Everything was fine, but what went wrong in production system, that we want to know from this. And it's about today's topic is about the disconnect between your CI/CD that tells you and what actually happens in your production environments. And we are going to see and we are going to challenge that the idea of a green pipeline is not always good. We will show how AI is changing the game and how you can start using it without spending a lot of money and using some other tools as well. We are going to use only open source tools here. Before I deep dive into the topic, I am Seema Saharan. I am currently working as an SRE at Autodesk. I am also a CNCF ambassador, public speaker, and AWS community builder. And I organize some of the events back in India for some of the user groups, CNCG, AWS, and HashiCorp user groups. My co-speaker is Aditya. He couldn't join us, but he recorded a special video for all of you. Hopefully the sound works.
Hello, Open Source Summit North America. I am Aditya Soni, a DevOps SRE engineer. I have worked at product and service-based organizations. I am one of CNCF ambassador too. I was not able to join you there due to some last-moment emergency, but don't worry, I have Seema there. Trust me, this talk gonna help you a lot with the issues you might be facing or your traditional monitoring tools missing, maybe in your CI or CD process. We will be covering how you can identify deployment issues missed by traditional monitoring tools with insights from AI, and how to leverage AI to analyze logs, matrices, traces for early problem detection. So let's stay tuned and see you.
Okay, first we will talk about why green deployments often gives you a false sense of security. Then we will look at what really breaks in production and why your monitoring stack often misses it. We will show how observability alone isn't enough. You need intelligence in your observability systems. That's where AI steps in. To detect anomalies, summarize your logs, spot issues before your users do. We will walk through a real-world example, show you how open source tools make it possible, and wrap up with the key takeaways that you can apply in your applications today. We have all been at this place that we can take an example of developers and SRE space. As an SRE, I am always worried about that I'm going to get a pager and what went wrong. I'm going to just ask the developer, what's the issue? What was the last deployment that you did? Was it any breaking change that you deployed somehow and it wasn't caught up in our test cases? So we do love the green pipelines, but it isn't always the right ones. We can deploy the breaking changes as well. So this is what we call the illusion of health. Your system looks fine, your infrastructure is doing fine, there is no spikes, you didn't see any alerts in your database, your caching systems, and even in your Kubernetes clusters, but your users are facing some issues. It happens at scale. Even large companies do face this issue, and that can impact majority of the users if larger organizations deploy that change. So that's the problem we are going to talk about today, the illusion of green pipelines. Let's talk about what went wrong. Traditional health checks doesn't capture business level failures. This type of failure doesn't come from infrastructure metrics like CPU or memory. It shows up in user behavior. It's hard to catch unless you are looking with intelligent systems. In your environments, think about silent errors. A mobile button that doesn't work, your page is just loading, and your users are not even able to log into your systems. Then if your application is identity system like an IAM platform, then your whole organization can go down. So we don't want that, right? But that's the question, why the pipeline was showing green? And we still got an alert, we got the pager at 3 a.m. and that's pretty nasty, because we are just like, okay, that's pretty bad, because at that state, we don't know what happened. And we might be in a state that we need to page a lot of other people as well that are dependent on that, that deploy those changes. So you probably been in a war room, and the first message that you get from your developer that the pipeline was green. Then what was wrong? But was the pipeline trustworthy? Was the green just like did it cover all the unit test cases, integration tests, all the edge cases that you might not have integrated in your CI/CD pipeline? And but there can be reason that you don't have those test cases integrated in your pipelines, right? And even if your test cases were included, there is always a case that you might miss a test case, and that will show up in your production systems, and your user will tell you that, hey, this API is having a lot of latency, we are not able to load it, and seriously, we don't want that. So the CI/CD gives you a confidence, but only within its scope, and that scope is really narrow. A real world example that we can take is for a fintech company. Let's suppose you're, okay, back in India, it's like a UPI payment, so we do all the payments online. Same can be applied in US, where our credit card systems went down for just a minute. It can impact a lot of users. Companies don't want that. So another examples can be a commerce website where you are not able to add your items in your cart. There can be like even 10 seconds of downtime in your applications can impact hundreds and millions of users as well. So we all know that traditional monitoring definitely falls short. And why it does that is, traditional monitoring relies on static threshold. Let's say if our CPU is above 80%, send me the alert. But for your particular application, do you really want your CPU to reach 80%? We don't, right? So even if with static threshold, we don't want that, and similar case will be for latency. If the latency is maybe around 200 milliseconds above, then you send the alert. But we don't want our users to be stuck in the loop and just waiting for the page to load even within like 50 milliseconds or something. Sorry, 500. But that logic assumes that you know the shape of every future incident. We don't know that. And as your application grows, as your APIs grow, as your user base grow, you need to modify your monitoring systems. And your monitoring system should be adaptable. You don't want to just edit your static thresholds every time you make a change. And it can be sometimes that you were not part of a team that you are currently working in, and you just remember that, hey, 2 years back this person did this change and we need to again redo the same work. We don't want that. So our monitoring system should be adaptable. They should be intelligent enough to adapt with change. So our logs are siloed, metrics are coarse, and traces are deeply disconnected. There is no connection between all of these things, and this means that we will have slow mean time to detect and slow MTTR. That means our SLO and SLIs are really bad now, and that can impact our business as well and our clients. Now we are looking for a solution. That's where comes observability with intelligence. You can have all telemetry in the world, logs, traces, metrics, and still miss the story. Observability tells you what happened. Intelligence tells you why and whether it matters. It's the difference between seeing a spike of 1% CPU and see that this can correlate to your checkout drop or users in mobile. And traditional dashboard don't give you that flexibility. And that's where you should try AI-powered observability. What does it mean? Now we enter the exciting part. AI can connect the dots where our dashboards can't. So for metrics, you can use Prometheus with PyOD to detect anomalies and use LLMs to summarize your detected patterns in logs as well. And also OpenSearch is a product where you can see the historical anomaly detection as well, because that's really important. It can see historical data and predict that as well. And we can use tools like Jaeger and custom anomaly detection for your traces and see the hidden latency in your APIs. And you can also use OpenSearch ML models as well, and you can write your own LLM models and integrate with OpenSearch itself. This is what we feel like when AI gives you wings. When where AI beats traditional alerts. So business logic bugs with no infrastructure symptoms, traffic pattern anomalies, slight variations in logs that humans can't detect, detecting new paths in trace spans. And yeah, that's the power of semantic and behavioral understanding that we can get from AI. Okay, let's break a deployment hypothetical case. We will see how traditional monitoring sees and what AI finds. So you have deployed your applications and all your pods are coming up healthy. It's 200 okay, everything is green, but 10% of your users are reporting that they are seeing failures in one of the APIs. It can be checkout, or it can be adding to the cart or something. Some API is showing that. And your logs, slight variations in errors, wordings, and your traces, one span in payment path is saying that it's 150 milliseconds slower than earlier. But none of these triggered any alerts. How would the developers and SRE know that this is an issue? And but within the same case, AI can group all of these information and detect it as an anomaly and sends you an alert that this is what you should look for, this is an anomaly. Some of the open source tools that makes this possible is Prometheus, PyOD, Grafana, OpenSearch, LangChain, Jaeger Open Telemetry Collector, and with Captain you can also define pre and post deployment activities and stages in your CI/CD pipelines, and also anomaly within your CI/CD pipeline. So here's where AI fits in. Post-deploy, you can run drift and anomaly detection immediately. You can use shift-left testing with tools like Captain, and like I said, that Captain also support pre and post deployment tasks and deployment observability as well. You can set up alerting that can detect semantic issues and sends it to your notification channel like Slack or Teams or email, anything that you are using currently. And behavior baselining, snapshot your system normal and compare every future release. And also the DORA metrics also plays a really important part here. Talking about the metrics, instead of saying that alert me if the latency is above 500 milliseconds, we can just use historical anomaly detection with OpenSearch or any other tool that you want, and that can detect that this is an anomaly. You should really see it, and this can detect slow degradation, spot usage anomalies on, let's say, big like Black Friday or 4th of July, where your commerce systems are really peak on the traffic. So that's where you can detect it, and you can use your alerting system as alert manager with integrated with Prometheus, obviously. And this is metrics with memory. For logs, you can use LLM models to summarize all the logging system, because going through petabytes of logs is not a human task. You will need a system that can just summarize and sends it to your Slack channels and see if any anomaly is detected. For traces, AI helps you read it, because we can't go over all the spans. Like for each API, it can be hundreds is a really less number, but millions of traces in a day, and you can't really go through that. And that's where you can use OpenTelemetry with Jaeger traces, and that can also you can also apply anomaly detection on spans as well, and that can show you your API performances, where on which span your API is taking a lot of time, and that you can improve the latency. That can be done. Some of the recap and takeaways. Green builds doesn't mean that you have healthy deployments. Open source tools and AI can uncover hidden anomalies today. Logs, matrices, and traces can be semantically analyzed, and you can always build this solution without a SaaS service as well. Thank you so much for listening in. You've been a great audience, and this is where you can connect with me or Aditya, and we can chat about more on LinkedIn or any other medium that you want. Thank you.
All right, thank you, Seema. All right, we have, looks like we have about, let me double check the time. Yeah, we have time for one question. Of course, I'm gonna go in the back. First one, I need my steps for the day, especially after lunch. All right, here you go.
So I actually, we've tried using AI for observability. First of all, the biggest challenge we faced is most of the observability tools, they are average of averages. Mm-hmm. So the larger context you provide to your AI, it dilutes down the values which you are providing them, especially with CPU, right? I run an application which is super heavy during 9 to 5, like we run 100 million transactions an hour. Yeah. But as soon as that 5 o'clock hits, mm-hmm. there is no usage of our CPU, there's no usage. And when we throw in such a noise, so much amount of data to AI, especially for anomaly detection, it averaged out the averages. And more data we provided it for, like, when you do it for just 2 hours, it makes more sense. When you do it for 1 day, it's like 33% of the time your CPU was running like 80%. After that, for next 16 hours, your CPU is like just sitting around over there waiting for transactions to come in. And what happened, right, with the AI anomaly detection, which when we tried it, it generated so much noise that at one point we were like, okay, we got to stop AI from reading any more anomalies. So like, have you faced anything like that? And like, how do you even resolve it? Because the problem with AI is it thinks every data is important, mm-hmm. right? And the more data, like you provide them 30 days of logs and it's going to start finding something which is anomaly, like probably has nothing to do it. I just have a 12 p.m. batch job running, has got nothing to do it. There is a small spike, but it will throw in Slack alert saying like, oh, you are having an anomaly. Have a look at it, right?
Yeah. So this is, we have faced this, but it's in our organization. So we are using a different tool there. And what we did is we configured the anomaly detection to not use automatic alerts for some time, because we need to analyze if the traffic is really important and is that considered a anomaly as well. So we have fine-tuned the alerts first thing, and also we are parallelly working on seeing how we can improve those anomalies. We are our developers are still working on that, and we found that anomaly detection is good because that improved our application, and we found some of the anomalies that we weren't even aware about earlier. So that's what happened in our use case, at least. Yeah.
All right, great. Thank you very much again. Appreciate it.
Thank you.